Good evening, everybody. So, we are discussing the model analysis. In the previous two classes, we discussed about the model analysis objectives, uses, and then the dimensionless numbers. And once the dimensionless numbers are obtained, then we have taken up Reynolds model. Once again, between the dimensionless numbers and model analysis uses, there is one more topic called as similitude. That means what type of similarities should exist between the model and the prototype so that the results predicted in the model can be applied to the prototype. So there are three types of similarities: geometric similarity, kinematic similarity, and dynamic similarity. It's easy to really achieve the geometric similarity and kinematic similarity, but it's difficult to achieve the dynamic similarity because the ratio of the various forces in the prototype and model at the corresponding points should be same, and they also should be in the same direction. In any problem, all the forces are not significant. So that's why without a proper compromise, achieving dynamic similarity is extremely difficult. So in order to simplify that problem, we have defined the dimensionless numbers. The dimensionless numbers are nothing but they are the ratios of the forces. And the dimensionless number signifies which force is significant, which force is really useful in a particular problem. So after defining the dimensionless numbers, based on the dimensionless numbers, in order to achieve the dynamic similarity, we have defined the model laws. There are five model laws, out of which the one Reynolds model law has been taken last time in the previous lecture. In this lecture, I will take another model law. Again, this model law is also to achieve dynamic similarity. So under what conditions this model law is applicable and this model law gives better results, that we will follow, and let us discuss on that. So in today's class, main discussion will be on Froude's model law. So today's discussion is on Froude model law, which states that the Froude number for the model is equal to the Froude number for the prototype. The model Froude number is V by root GL for the model is equal to V by root GL for the prototype. And if we are conducting the experiments, also the model experiments at the same location where the prototype is going to be built, naturally the G for model and G for prototype both are same. Then we can write it as Vm by root Lm is equal to Vp by root Lp. Or I can write Vp by root Vm is equal to root Lp by root Lm. So it is root of Lp by Lm. So it is root Lr. So the Froude's model law says that Vp by Vm is equal to, that is the velocity scale ratio. which is equal to VR is equal to root LR. This is very, very important in case of Froude's model law, basically. And then Froude's model law, basically, when it is applicable, when the gravity force is predominant, then this model law is applicable, right? What are the situations where you apply the Froude's model law? Especially free surface flows. Wherever free surface flow is there, that is flow in a canal, flow in open channels, flow over a spillway, wherever the water surface is exposed to atmosphere, flow over weirs. So all these cases we apply Froude's model law. That is number one. Number two is a flow of jet from a nozzle, right? Then basically problems where waves are likely to be formed. That means where the waves are formed means, for example, in the oceans, if a ship is moving, naturally it is subjected to the wave motion also. This is one of the examples. Then last, if fluids of different densities flow over one another, then actually this Froude's model law is applicable. So finally, what is Froude's model law? Already I explained. What is most important thing that you should remember using Froude's model law is VR is equal to root LR. This is the takeaway from the Froude's model law, which is very, very, very important actually. Once this scale ratio is over, then we have to basically define the scale ratios, define scale ratios for number one, time, number two, acceleration, number three, basically discharge, number four, force, number five, basically pressure intensity, number six, work, energy, torque, moment, last seven, power. So for all these variable parameters, we need to find out what is the scale ratio. All these scale ratios are determined based on the fact that VR is equal to root LR. This is the basis for all these things. So based on that, now I will show you how I will do that one after the other. For example, one, if I take it, the first one is scale ratio for time. Scale ratio for time, if I take it, you know that basically for time is equal to, if you take it, it is length by velocity, right? If I take it like that, so or otherwise, TR is equal to TP by TM. TP by TM means L by V to the prototype by L by V in the model. So it is LP by VP divided by LM by VM. So if I do it, it is LP by LM into, basically if I take this, VM by VP, right? Or LP by LM means I can write it as LR, and VP by VM is equal to, I can write 1 by root LR. So this, if I do it, what is happening actually? Then it is going to be root LR. So first thing is TR is equal to time scale ratio is equal to root LR. This is first one. Then second one, acceleration square ratio, which is AR. AR is equal to, it is VR by PR. VR is equal to, just now we found how much, what is VR? It is root LR. What is TR just now? Root LR. So acceleration scale ratio is 1. This is number 2. Or you can derive the same by writing the whole dimensions. No need actually, better avoid. Don't make it complicated, right? Once 2 is over, what is the 3? Discharge. Discharge is equal to volume by time. Volume means what? LR cube. Time means TR. So what is TR is equal to root LR. LR cubed by, this is root LR, right? Then what will be happening? LR by basically this. If I do it, it is LR to the power of 2.5. So QR is equal to LR to the power of 2.5. Then fourth one. What is fourth one? Force. Force is equal to, what we have is rho L square B square. If I do like this, so FP by FM is equal to, that is FR is equal to rho P LP square VP square divided by rho M LM VM. Assuming that this is the same fluid, then naturally this becomes 1. So therefore, it is LP by LM square is nothing but LR square by basically VP by VM square means it is VP by VM itself is root LR. So naturally LP VP square by VM square is equal to, we can write LR. So naturally it will be LR cube. So force scale ratio will be LR cubed actually. So this is the next point. Once force scale ratio is over, then fifth one which we take it up is pressure intensity. Pressure intensity is nothing but actually force by area. And force, just now we do know it, LR cube, right? What is area? LR square. So naturally pressure intensity is LR. Then coming to, then basically sixth one, if I take it, What is basically, for example, if I take it to torque TR is equal to not time, it is torque TR is equal to force into length. So that is equal to force is equal to LR cube into LR. So it is LR to the power of 4. This is torque. Next, work also same force into length LR cube into LR. So LR to the power of 4. Right? Then if I want next power, power is equal to work by time. So LR to the power of 4 divided by this is root LR. So LR to the power of 3.5. This is for power actually. So these are the various scale ratios that we should remember. If I take in one simple stroke actually, what are the things that which we discussed? For example, this is the scale ratios, right? Scale ratio. This is we take it as quantity. And all this is based on Froude model law. So first one is velocity. Velocity is VR is equal to root LR. Then time TR is equal to root LR. Third one is acceleration. Acceleration is equal to 1. Fourth one is discharge. Discharge is equal to LR to the power of 2.5. That is discharge. Then after discharge, then force. Force is equal to basically which we found out LR cube. Then after force, then we have taken up basically pressure intensity. Pressure intensity is equal to LR. The next one which we have taken is work, energy, moment. All these things, if you take any of these things, for all these things, it is LR to the power of 4. And last item which we have taken, power is equal to LR to the power of 3.5. So this we should remember in this case. Now, based on this, many number of problems we can solve in the case of the base using Froude's model law. One problem I will take it up. For example, in 1 is to 40 model of a spillway, the velocity and discharge are 2 meters per second and 2.5 meter cube per second. Find the corresponding velocity and discharge in prototype. So in 1 is to 40 model actually 41 means actually LR is equal to it is LP by LM is equal to 40. That is what he has given. And what he has given, VM is equal to 2 meters per second. And similarly, QM is equal to 2.5 meter cube per second. And what is required actually? What is VP? And second one is what is QP? These are the two questions that are being asked. So for us, VP by VM is equal to, based on Froude model law, Vp by Vm is equal to basically root of Lp by Lm. So first doubt normally which you come across in this problem is how Froude's model law should be used, or why Froude's model law should be used. So the moment you have seen spillway means it is a free surface flow. Wherever free surface flows are there, Froude's model law is applicable. That is the reason. So if I take it, Vp by Vm is equal to root of, it is 40, right? Therefore, Vp is equal to, Vm is how much he has given, 2 into root 40. So if you put 2 into root 40 is nothing but 12.65 meters per second. Similarly, for example, if I take it, QP by QM is equal to, but even if you don't remember the direct, basically LR to the power of 2.5. If suppose you don't remember this also, doesn't matter. You know QP by QM is equal to, it is some volume by time. What is volume actually? LR cubed. What is time actually? Which one we will take it? Root LR. So this will be becoming LR to the power of 2.5. So if I remember this actually, I put it QP by QM is equal to, what is LR actually? It is LP by LM whole to the power of 2.5 basically, right? What he has given already, this is 40 to the power of 2.5, and QP is equal to, QM is how much? 2.5 into 40 to the power of 2.5. So this will be equal to basically 25298.2 meter cube per second. So this is another problem. Like this, second problem, I will take it. A ship model of scale 1 by 50 is towed through seawater at a speed of 1 meter per second. A force of Q Newton is required to tow the model. Determine the speed of the ship and the propulsive force on the ship. If prototype is subjected to wave resistance only. Again, read the problem. First the thing is ship model. Last one is subjected to wave resistance. The moment I see this wave resistance, immediately we conclude Froude model law is applicable. This is the first conclusion. Then what is it? 1 by 50. 1 by 50 means Lm by Lp should be equal to 1 by 50, or Lr is equal to, for us Lr means Lp by Lm is equal to 50. This is first thing. Then the model is, well, model velocity, how much he has put? 1 meter per second. Force of 2 newton to the model. Fm is also equal to how much actually he has given, basically 2 newtons. What he wants, determine the speed of the ship and the, what is Vp. Vp is equal to how much? What is Fp is equal to how much? These are the two questions actually that you have. So let us take it. What is Vp by Vm as per Froude's model law? It is root Lr. So that means root of 50. Therefore, Vp is equal to Vm into root Lr. So therefore, Vp is equal to, what is Vm? 1 into root of 50. So this is first answer. That is over. So that means if you do it, it is going to be 7.071 meters per second. Then next, what is Fp by Fm is equal to, you have already done it. It is Lr to the power of cube. How we got this also we will check. Force means actually we mentioned rho L square V square. So rho is for model and prototype same. So that means L square means LR square. V square means actually root LR whole square. So that means LR square into LR. So that means LR cube. This is thing. So now if I take it, what is Fp is equal to Fm into Lr cube. So Lr cube means Fm is how much he has given, 2 into Lr is how much, 50 cube. So naturally if I do this exercise, I'm going to get 250 kilonewtons. So this is another problem, right? One more problem also we will take before closing. In a geometrically similar model of spillway, the discharge per meter length is 1 by 6 meter cube per second. If the scale of the model is 1 by 36, find the discharge per meter length of the prototype. In a geometrically similar model of the spillway. So the moment spillway you have seen, you can say Froude's model law is applicable. Discharge per meter length is is Similar model of a spill 1 by 6 meter cube per second. Scale of the model is 1 by 36. That means what is it? Lm by Lp is equal to 1 by 36. Lr is equal to Lp by Lm. So it is 36. First thing. Then over. If the scale of the model is find the discharge per meter length. So first let us write what is QR. QR is equal to QP by QM. And already we know that it is LR to the power of basically 2.5. Right? How we got this also? You can write what is Q volume. It is volume by time. What is volume scale ratio? LR cube. What is time scale ratio? Root LR. So what it is going to be LR to the power of 2.5. Therefore, QP is equal to QM into LR to the power of 2.5. QM is what? 1 by 6, right? Into what is LR to the power of 2.5? Basically, if I take it, this is 1 second, 1 second, a small deviation, right? This is also right, but here a little bit we need to make it. Then that fellow has done one small correction here, right? In the problem, if you see, this is discharge. In the problem, what he has given discharge per meter length. That means what? QP by LP. This is what discharge per meter length and QM by LM. This is what. So this is what we call it as if I take that, then naturally what will happen? Q, if suppose I take QP by LP divided by QM by LM, if I take it, is equal to LR to the power of 2.5. Therefore, this is discharge per meter length. I can write this as small qp divided by small qm. That fellow has given only small qm. Therefore, basically, if I take it this way, how this also will be changing actually. So now if I take it this way, yes, right? If this has to be changed to LR to the power of 2.5 by LR, because this LP by LM, if I put it, is LR to the power of 1. Why this LR to the power of 1.5? QP by QM is equal to LR to the power of 2.5. This is fixed. But what we want is QP by QM is equal to how much? So what is QP? This is the discharge per unit length. So therefore, if I do this, this will be equal to LR to the power of 1. So if then in that case, what is QP is equal to QM into LR to the power of 1.5. So that QM is 1 by 6 into LR is equal to what he has given. LR is equal to for us 36 to the power of 1.5. So if I calculate this, it is 36 meter cube per second per meter length. So final answer is QP. QP is equal to 36 meter cube per second per meter length. So this is not capital Q, this is small q. What is the difference between small q is equal to capital Q by L? This is what we call it as the small q. So if I take it for Q, I already know it is LR to the power of 2.5 by L. So for small q, what it will be? LR to the power of 1.5. This you should understand. So this is again. So with this here, I will stop the problems actually. We will do more number of problems as we move into the what you call it as at the end of this topic, we will do the more number of problems. So I will stop my lecture at this stage and then I will take you into the next one. Then, in this class, we have only studied about Froude's model law and its applications that we have studied. In the next class, we will take up the other model laws also. And at the end, we will solve some 5, 6 problems on various model laws at the end. So, we conclude here the Froude's model law.
Like, share, and subscribe. Hit the bell icon for more updates.